Hello, viewers. I hope you already watched the part 1 of the preliminary design and development. Now, let me take you through the part 2. Preliminary design and development, part 2. Now, let's see what are the learning objectives here. So, first, let's get to know what is the design optimization that is done on our machine according to the advanced design criteria. The second thing is I will explain you on the mockup analysis. Next, on the DFMEA. And finally, we will see what is the design review and the release process that is followed in the preliminary design and development process. Firstly, let's look into what is the design optimization that is being done according to the advanced design criteria. The first criteria that we have is the design for packaging. It's nothing but the control of the geometry. I hope you remember this. So we have to package our design in such a way that it doesn't clashes with the adjacent systems. Okay? Yeah. Now, if you observe the gate of the divider very carefully, after rotating by 120 degree from the right to left, it is just touching the wall. So it is not clashing with the wall. Okay, so this we have to keep in mind that the moving object doesn't touches the stationary object. Okay, so this is one of the example. I mean, one of the simple example to explain the control of the geometry. Okay, the next example is the support bracket design to meet the design for packaging demand. You can observe that this wall of the bracket is almost parallel to the wall of the divider, and resultingly this wall of the bracket is perpendicular to the axis of the gate. I mean axis of the stem of the gate. So if it was less than this particular angle, then it would have clashed with the yoke. So the designers have taken care about this. And here also you can observe that this wall is exactly parallel to the profile of the worm wheel. Okay. Moving on, design for assembly. Yeah, this is the concept design and the development data without any locator. So this is the PDD data with the locator. If I take a section through the locator, you can observe here that the divider is just resting on the stand. Okay, and the locator is just touching over here. Imagine that if there is no locator, in that case the operator has to hold himself in one hand and he has to screw the or he has to fasten these screws with another hand, or he has to take the help of another operator to do this. So this locator acts as a self-locating feature for this divider. Moving on, design for manufacturing. That is the sheet metal bending operation. If you look at the concept design data for this particular bin, so I had just modeled it uh, to get the shape for this bin, but this is not easy to manufacture. Now, if you look at the preliminary design and development data, so this bin is formed by folding these four walls and joining them towards each other with the help of the welded joint on all the four corners. Okay, see, sometimes the designers, if they have time, they also uh, consider the design for manufacturing criteria while doing their 3D development. But if they don't have time, they just model it to get the shape of that particular object. The next design criteria that I'm going to explain you is the design for assembly. Basically, this is the design for sequence of assembly. So to explain this, let me take you through the model. Okay, now let's see the assembly sequencing for this particular machine. This is the environment data that is available with us from the customer. So the customer has provided us with all this available data. So for this data, what we observe here is we have the quality testing machine, which is mounted onto a stand here. Now the first step from our side is to fix the net. So let me bring the net over here. Okay. So after bringing the net, so I have to fix this with the help of a bracket. So friends, what you can observe here is I have brought the bracket here and I have fixed this net using this bracket and these two self-tapping screws. Okay. So as you can observe here is these are the M6 self-tapping screws. So since I couldn't find the self-tapping screws in my library, I have fixed them with the normal hexagonal head screws. Okay, so this is the first part that we have to fix. The second part is to bring the divider or the channel, which will channelize the fruits to the bins beneath. Okay, let me bring the divider here. Okay, so this is our divider. This divider comes pre-assembled with this gate, and here there is a bush that has to be installed as a standard part at the assembly line itself. So since I don't have that bush in my database, I couldn't bring that bush here. But before installing the gate, you have to install the bush here, and the bush is nothing but it is made up of the gunmetal bearing on one side and the um aluminium cylindrical bush on the other side, which gets fitted onto the divider. So the difference between a normal bush and this bush is that this bush is having a gunmetal inside which acts as a bearing. Okay, so once this divider gets pre-assembled with the gate, so you have to bring that sub-assembly here to the main station, and after that you have to fit this gate again onto the stand using a self-tapping screws. Let me bring those self-tapping screws here. Yeah, so these are those self-tapping screws which I have brought here. The next part that forms the sequence in this particular assembly is the bracket, that is called as the support bracket. So this support bracket is also fixed onto the stand using the self-tapping screws. These are the flanged flanged head self-tapping screws, M6 self-tapping screws. You can also create the hole on the stand and then fix it. It's not a big deal. As you can observe here that the gate is not complete. It is having a small stem which is projecting behind the divider here. Okay. So the next part in this assembly sequencing is to bring the yoke which gets fitted onto this stem. What is that part? Yeah, so this part. Yeah, friends. So I have brought this pre-assembled yoke along with the sleeve here. This portion is called as a sleeve which gets fitted onto the stem. So the pre-assembled sleeve and the yoke assembly is brought here. As you can see here that this is a oversized hole which can fit this particular sleeve. Let us see what is the dimension of this particular sleeve here. Yeah, the dimension of this sleeve here is 8 millimeter. And let us see what the dimension of this hole. Maybe I can take a section here to explain you better. Yeah. So let me say okay to this sectional view. And what you can observe here is that the sleeve has fitted onto the stem by means of the interference fit, or you can add a set screw here to fix this. So both is acceptable, no doubt about that. Yeah. So you can see here the diameter is 10 mm and the diameter of this sleeve is 8 millimeters. So we get the radial clearance of 1 millimeter to fix this particular assembly onto the stem of the gate. Okay, fine. So the next part comes in this assembly. Here is the spacer, which is a part of this universal joint. As you can see here that this is nothing but a universal joint here. So let me bring that spacer over here. Okay, and after getting the spacer, let me bring the pin to lock it. Guys, you are all engineers and you know how the universal joint works. Yeah, so after fixing this, what we have is we have to insert the worm wheel. Yeah, so this is the next assembly which has to be inserted through this bracket. And what you can do here is, before assembling the next part, that is the other portion of the universal joint, that is the yoke, you can just pull this worm wheel little bit backside. Let me pull that a little bit backside here. So I'm going to pull this backside a little bit. Okay, so I'm just going to pull this and bring the second yoke here, and again insert this back into this yoke so that this fits perfectly here. Okay, so now you can see here friends that the second yoke, we have already assembled the second yoke here. And once it gets assembled, let me put the pin on the either sides, both bottom as well as on the top. Once we fit the pin, so let me bring the other portion of the gear set, that is the worm here. Okay, so this is not properly aligned. Let me push this little bit inside here. Okay, so as you can see that here also we have the oversized hole. The dia of the worm is 8 millimeters and I have inserted this worm through this hole, and the dia of this hole is 10 millimeters. Okay, so this forms the complete gear joint of the worm and the worm wheel and also the universal joint. So this is the complete assembly sequencing of this particular assembly, that is the worm and the worm wheel. Yeah, we still have two parts left to be kept below this divider, that is the bins. Yeah, let me bring up those bins here. Yeah, so as we observe here that the main important points is, so in our concept design, this particular item, that is the gate, it was a single piece which was mounted onto this yoke, but now we have split this into two parts, that is the gate along with the gate stem and the sleeve separately. So this allows us to sequentially assemble this particular part, one from this side, I mean from the front of the divider, and another part from the back of the divider. So this is how the assembly sequencing or the design for assembly sequencing plays an important role while designing any machine. Okay. Moving on, The next step that we have in our preliminary design and development process is the mock-up analysis. What is mock-up analysis? Mock-up analysis is a study to find the clash, clearances, and other detections within the system or between the systems. Additionally, apart from this, the team also gives us the analysis reports of the mock-up done for our particular assembly, so that the product development team can incorporate them into their design and remove all the clashes or the issues. Now let's look at what are the different steps involved here. The first step is the detection of the clash. In clashes, we have two types. One is the internal clash and one more is the external clash. Now let's see what are the internal clashes. For this, I am taking the same example, that is the gate and the divider. You can observe here that the gate is little bit longer, which is clashing with the wall of the divider. The second example that we have is the wall of the support bracket, which is clashing with the yoke of the universal joint. And the next clash is between the spacer and the second yoke of the universal joint. So these are all the clashes that we generally come across while designing the machine or something. So these are basically tracked or found by a separate team from the vehicle architecture. They are called as a packaging team. And if the designer misses to follow any of the design for packaging rules, then he ends up in the clashes like this. Now let us look at what is the external clash. The external clash is between two systems. So this example is from the process industry. Here you can see that we have the piping system which is running inside a chamber and the structural system which is a part of that chamber. Here the member of that structural system is clashing with the pipe here. So this is the example of the external clash. Now moving on, let's see what is the next step in the mock-up analysis. It is the detection of the clearance. So for that, I have the example of the interior of a car. So this is the picture showing clearance between the A pillar and the dashboard of the car. You can observe here that the clearance is too much in the middle and it is very least at the ends, and the rectified version of the same. You can observe here that the clearance is uniform throughout this zone, so that the dashboard maintains a uniform clearance with respect to the A pillar trim. Okay. The next step is detection of the holes mismatch. And this is a common problem which we generally come across. So this blue part is the part of the another member and the gray color part is the frame or the structural member on which this blue part gets mounted. Okay. So fine friends. So these are all the steps that are involved in the mock-up analysis. We will continue again in the part 3 where I will explain you on the DFMEA and the other steps of the preliminary design and development process. Stay tuned until then.